All right, we're working on 1.2.3 rational expressions. Again, I'm using the checker problems, so 1.1.2 or 1.2.2, sorry. Um, and then I got the first question, third question here. What is the value of the rational expression when x is equal to 2? So, there we are. So it says when x is equal to 2, all I'm going to do is in my expression down here is I'm simply going to plug in 2 for the x and evaluate. So I'm going to have 2 plus 9 over 2 plus 5. That's going to be 11 over 7. That was it. That's done. We're done. So what is the value of the rational expression when x is equal to 2? It is 11 over 7. I just plugged the 2 in for the x's and solved. For number 3, what is the value of the rational expression when x is equal to -1? Again, same idea. I'm going to plug that in for my x's. So I'm going to do that to the side this time. We'll have -1. Always like to use parentheses around my negatives. Plus 3, 4 minus -1. I especially want to use a parenthesis when I have another minus sign so they don't kind of bleed together. We have -1 plus 3 is going to be a 2. 4 minus -1 is going to be 4 plus 1, which is going to be 5. So the answer to this one is just 2 over 5. So these are pretty simple. They want us to evaluate, or what is the value? You simply plug in the number in for all the x's that you see, and then solve. Go to the second page. For questions 5 through 7, determine when the rational expression is undefined. So the word undefined, which I don't think you can see so undefined. You are undefined when you divide by 0. So 7 over 0 is, you can't solve it. You can't divide by 0. It is undefined. So the word undefined tells me denominator. So I see undefined, I'm going to think denominator. So here's my first question. They want to know for what values of x is a rational expression undefined. I'm not worried about the top at all. I'm simply going to take the denominator and I'm going to set it equal to 0. And then I'm going to solve. Plus 6, x equals 6. So this rational expression is undefined when x equals 6. All right, so down here, same thing. I don't care about the numerator. We want to know what's undefined. So I take the denominator and I set it equal to 0. So we have 2x minus 8 equals 0. We'll solve for x. What's on the same side as x? Well, the 2 and the 8. What's the furthest away? The 8. What is it doing? It is subtracting. So I'm going to add both sides. And I still have 2x equals 8. And rewrite it. I'm still solving for x. What's on the same side as x? Well, the 2, what is that 2 doing? It is multiplying. How do you get multiplication? You divide. So x is going to equal 4. So when x equals 4, this rational expression is undefined. Going to my next slide here. For questions 8 through 10, determine the value of x for which the rational expression is equal to 0. So before, when we were undefined was talking about the denominator. Now when we want the rational expression to equal 0, now we're talking about the numerator. Okay, let's pull this one out. So numerator, that means I don't care about the denominator. All right? And now if we look, we actually have 2 pieces of the numerator. They're multiplying together. So what, instead of only having 1, I'm going to set equal to 0, I'm going to have 2. I'm going to have x plus 4 equals 0, which is going to give me x equals -4. And then we'll have x minus 2 equals 0, x equals +2. So the rational expression x plus 4 times x minus 2 divided by x plus 6, it is equal to 0 when x equals 4 or -4, and when x equals +2. So these right here are my 2 answers that make this rational expression equal to 0. So going down here, same thing. I don't care about the denominator because I want to know what makes it equal to 0. This is numerator only. I'm going to take that numerator and I'm going to set it equal to 0. I'm going to subtract 10. So I have 2x equals negative 10. And I'm going to divide by 2. X equals negative 5. Boom. That's it. As always, if you have any questions, please reach out to me using my email, my little Google Voice number that you can text, or just come into my classroom and ask.